Welcome! My name is Andreas, and in this video I will walk you through the PinPoint Manager user interface and demonstrate basic targeting and payload control. Familiarizing yourself with the PinPoint Manager software will ensure that you can use it efficiently in hectic and stressful situations. With proper use of this software, the PinPoint system will act like an extra pair of hands to assist the crew in mission-critical situations. This is the PinPoint dashboard. The dashboard is designed from the ground up to be both touch-friendly and mobile-friendly. The dashboard is divided into two sections. On the left side, we have the map. The map displays our own vessel, any nearby AIS positions, and any active targets. Map behavior can be configured using the controls at the bottom. The map can also be maximized when needed by clicking the button in the lower right corner. Moving over to the right side, we have the control area. Here we have a list of nodes at the top, and below we have a list of targets. Let's look at the node list first, but before we do that, let me explain what a PinPoint node is. A PinPoint node is a combined unit consisting of a gimbal stabilizer with an attached payload. The payload can typically be a searchlight or an infrared camera. A PinPoint node will accurately track a target with a precision of up to 0.05 degrees and is actively stabilized to compensate for pitch and roll movements across its full range of motion. The maximum movement speed of a PinPoint node is up to 360 degrees per second in normal mode and can be increased to 450 degrees per second in turbo mode. Currently, we have two nodes connected, a searchlight and a camera. However, it's possible to connect and control any number of nodes to a single PinPoint Manager instance. In this video, we will focus mainly on the searchlight. If we look at the top section of this node tile, we can see that we have a number of status indicators. We can see that the node is connected, that the tracking is not active, and that the payload is disabled. Then there's the target indicator. Whenever the node is tracking a target, its name will be displayed here. And then we have the payload controls. These are used to control the payload, such as switching it on and off. Below that, we have the control mode selector. The default mode is automatic, but it's also possible to use joystick mode, manual mode, and demo mode. In this video, we will only use the automatic mode. The other control modes will be covered in a separate video. Finally, we have the park button. This button will always make the node go to its parked position and turn off the payload even if it's currently tracking a target. Then we have the target list. A target can be created either manually or automatically. To create a target manually, you can use three different methods. The first method is to simply click on a location directly in the map. This will open the Add New Target dialog. The dialog will be pre-filled with a randomized name and the latitude and the longitude coordinates of the position that you clicked on. The target name can be changed to something more intuitive. Optionally, you can also specify an altitude. At the bottom of the dialog, you can select an available node to immediately start tracking this target. Let's select the searchlight node. Now, click Save and we can see the searchlight node immediately swing into action. Now that we are tracking a target, we can turn on the payload. This type of target is basically a fixed location, but you can change the location of the target if you want to. Simply click on the target and hold, and you can drag it around on the map. This will reposition the target, and the node will automatically follow it around as you relocate it. Let's turn the payload off again. To stop tracking the target, simply deselect the node on the target tile. This will automatically return the node to its parked position. The second method is to click on an AIS vessel in the map. This will open a pop-up with any known details about the vessel. You can then click the Target this vessel button. Again, this will open the Add New Target dialog, but this time the dialog is pre-filled with the vessel name and, if known, the MMSI number. It's recommended to check the Extrapolate Trajectory option for best tracking performance with AIS. Select the tracking node and click Save. Again, we can see the searchlight node immediately swing into action to track the vessel. And as before, we can turn on the payload. If we want to stop tracking this vessel, simply deselect the node on the target. This will park the node and automatically disable the payload. The third and final manual method to add a target is to click the plus button in the lower right corner of the target list. This will open the Add New Target dialog once again, but you'll need to fill out all the details manually. This can be useful if you want to track an MMSI number that is not yet in AIS range, for example. Now we will see how targets can be created automatically. Currently, this can happen in 3 different ways. From an ARPA radar, either through NEMA 0183, NEMA 2000 or a TCP/IP connection, or by receiving cursor on target messages in the PinPoint backend, and finally by receiving targets through a REST API in the PinPoint backend. These targets will show up automatically in the target list when they are received, and the operator can then choose to track these targets using one or more nodes. I will now run a radar simulator to demonstrate how this works. The radar simulator is now running, and we can see the radar targets are showing up in the target list. The radar targets display some extra information that we receive from the radar, including the target ID, the target name, the bearing, the distance, the course, and the speed. When a radar stops tracking a target, the target will eventually be automatically removed from the target list in the PinPoint Manager. So if I stop the radar simulator, in a few seconds the radar targets will disappear. Here are a few tips and tricks that may help you use the PinPoint Manager more efficiently. When you're working with multiple targets, you can easily change which node is tracking which target. So let me assign the searchlight to this target and the camera to this vessel. If I want to change which node is tracking which target, I can simply use these selectors to do that. I can track a single target using multiple nodes, or I can track multiple targets at once using multiple nodes. The payload is always controlled from the node list at the top. The available payload modes for standard S300 searchlight are on-solid, strobe, and SOS. Note that the payload will turn off automatically when you stop tracking a target or park the node. PinPoint nodes have a full 360-degree view on both the pan and the tilt axis with no rewind. This means that you can keep targets in view uninterrupted as long as they are in line of sight. However, with this freedom of movement, it also means that you may want to restrict the payload from being enabled when facing certain directions, such as the bridge of the vessel or crew compartments. To achieve this, you can add field of view restrictions. To do this, simply go to the Node tile and click on this menu icon, select Configure, and then at the bottom you will find a field called Field of View Restriction. Here you can click on Add Field of View Restriction, and you can select the zone in which the restriction will be in effect. You can select a pan from and a pan to, so I will set this to 90 degrees. You can select a tilt from and tilt to, and you can select the limit mode. The limit mode decides whether or not the restriction is effective when the node is outside this limit or inside this limit. I will use inside in this case. This means that if the node is moving with a pan value between 0 to 90 degrees and a tilt value between 0 to 180 degrees, the payload will be forced to be turned off. So let's test this. Let's put the light straight in front of the vessel. Let's turn the payload on, and I will rotate the light around. Now the light entered a field of view restricted zone. And we can see here, it says on the node tile that the current field of view is restricted and that the payload is temporarily turned off. If I move the light outside the restricted zone, it automatically turns back on. Let's park the node. That concludes this walkthrough of the PinPoint Manager user interface and the basics of targeting and payload control. We have covered how to create and manage targets, how to assign nodes to targets, and how to control payloads effectively. With a bit of familiarity, PinPoint Manager becomes a powerful and reliable tool, especially in situations where accuracy and speed matter. If you would like more details about the PinPoint system, you can find contact details in the video description. Thank you for watching and see you next time.